Okay, let me have a recap with you about the finite element. Okay, this is the most important part of your first lecture. By the time of quiz, still have a lot of students forget about this procedure. Okay, they find this spring is so simple, they write force over K. Okay, that works perfectly if you have one spring. When two springs are parallel, you can still do your whatever method. But when you start having 3 spring, 4 spring, sorry, you really have to follow the first finite element model. Okay? How do you model this spring? You have a spring, left node, right node. What's the equation here? Is the force balance on node 1 and node 2. Okay? In your lecture or in your most of the books of finite elements, they teach you procedure, okay, but they don't teach you the mechanics and physics. But for our part, we try to iterate and repeatedly highlight that you are doing the nodal force sum, okay. This will balance with the internal spring force. The left hand side here is your internal spring force. Okay? But your internal spring force has a standard way of writing. What's the standard way? The stiffness matrix is standard. Once you know this is K1, the matrix is always, first row is K1 minus K2. The second row is minus K1, K1. Multiply with the left node displacement U1, the right node displacement. Okay? So when you are defining this, for the first element, you write the element table. Element number 1, not on the left, U1, not on the right, U2. Elastic quantity, K1. And what you have here is stiffness matrix. You can recall from the computer program U1, U2, and F1, F2. Okay? So I can tell you that this kind of procedure is not out of the blue. If you go to do the N6 database, okay, I did that. They really ask every entry. Element 1, let's know, right? K. Okay, then they formulate that. And then next, the second element. Second element is the one at the bottom with not U3 on the left, not U4 on the right. Again, you have to write the force acting on the element F1, F2, but that external force, you don't do the component yet. Okay? You will do the sum later. But the element stiffness times U3, U4 is a standard procedure. So once you have element stiffness and element forces, you do the sum, and that element external forces will sum up to be equal to the total external forces. Okay. 所以同学这个清楚吗？ So you must make sure you are familiar with the procedure. Okay, no more your simple Hooke's law. Okay, everything go by metric method. Define coordinate for each node. All is rightward positive, rightward positive, rightward positive, rightward positive. Treat yourself like a computer. No reverse convention. Okay? And then form this table. This table is to remind you how to fill up the element stiffness. Okay, you see element 1, element stiffness is K1 minus K1 minus K1, K1. Element 2 is K2 minus K2 minus K2, K2. Okay, so right almost as a computer. So even though the grouping of the force is by element, but the force summation is by nodes. Okay? So you are actually doing the model force summations. And then this, before the name of final element, this is called matrix solution. Okay? So we have that already. So this is the basic one. Okay. Next we come to the procedure now. It's a recap. You have to define the node. 1, 2. Define the nodal displacement. Define the properties. Okay. Form the table and nodal associations. Define the local element stiffness. Okay, in your textbook, you talk about example of the global stiffness. This is unnatural. What you did is you are doing nodal force summations. Okay, there are no such thing. Why stiffness add up? No, stiffness add up is because you do add up the force. Okay, you don't add up the stiffness arbitrarily. Okay, if anything wrong, it must be you don't define the nodes properly. Okay, you only do the force summation. Okay, and then next do the solution. Yeah. Okay, we'll go through with another example so that you get familiar with that. If you now have two springs in series, the first spring has stiffness K1, second spring has the stiffness K2. Then you are going to break them up into these. Okay. Yeah, because I didn't write the table, so many of you didn't pick up the scale. Let me see how you do properly. Okay, if you really have this problem, what you have to do first is let's write this element nodes table. What do you have? First thing you got to do is write the table. So this is element number. Property. Sometimes you have a K directly. Sometimes you might have area or whatever. In this case, you have element 1, left node is 1, second node is 2, and the property is K1. You have element 2, left node is 2, third node is 3. Visually, you can see